Good morning, students. Welcome back to online PTSP class. In the last class we have discussed the three random variables: Poisson's random variable, normal random variable, binomial random variable we have discussed. The one more random variable we have to discuss in the second unit. With that, all the random variables will be completed. That one is called exponential random variable. As I told in the previous classes, binomial and the Poisson distribution is for the discrete variables, random variables, whereas the normal or Gaussian variable or the Gaussian distribution or the normal distribution is for the continuous random variables. So now I am going to talk another distribution that is named as exponential random variables. That is comes under exponential distribution function. Here this exponential distribution function is also valid for the continuous random variable, so that continuous random variable is a one which can have the infinite values for the infinite time instants. Here I am going with the continuous random variable is x. Continuous random variable I am assuming that is capital X. A continuous random variable x is called exponentially distributed with the parameter is a probability density function fx of x is equals to lambda into e to the power of minus lambda x. X must be greater than or is equals to 0. If x is negative, we can't get any value, that will be 0 only. For x is 0, then distribution function whose value will be 0, so that exponential function has been defining for the all the positive values of this random variable only. If you go with exponential of any negative value, that will be the 0 only, irrespective of any value, irrespective of any coefficient also, that lambda is a coefficient, so that we can have that value is 0, so that here exponential distribution function or exponential distribution with respect to the exponential random variable, that is capital X, is defined for all the values and values of x, and that x is nothing but it is a continuous random variable. Continuous random variable is a one which will keep on changes, that is called continuous random variable. Here if the lambda is greater than 0, if the lambda is 0, obviously this whatever may be the value of e to the power of minus value will be there, that will be 0, so that lambda is 0, 0 into anything 0 will be, so that we must select the lambda, that is a coefficient value must be greater than 0. Then only we can have the valid exponential distribution for the continuous random variable, that is exponential function capital X. Lambda greater than 0 if the probability density function of the probability density function, in short we can call PDF of the exponential random variable, is given like this, so that by choosing the random, by choosing the lambda is greater than 0, by selecting the lambda is 1, we can have this distribution, that is probability distribution is like this. Probability distribution will be like this. This is value of fx of x, and by choosing the lambda value is 1 or any constant, and we are going with the values of x, that is a random variable, and these are the continuous variable. That means what? Here we took the value of 0 and 2, that means what? Indirectly we are saying that we chosen all the values between the 0 to 2, so that the corresponding distribution function fx of x is also continuous, and here the random variable value x is also continuous from 0 to 2. In that case, the x value is also continuous from 0 to 20, so that the probability distribution function is also continuous from 0.0352 and it is almost 0. So that continuous random variable is nothing but the x value, the random variable value must be continuous with respect to the probability density function, that is fx of x, so that the value which has been keep on changing with the infinite times, and that is named as a random variable, continuous random variable, and this distribution is named as exponential distribution. Here if you go with the one particular thing here, this value of the probability density function has been decreasing with respect to the value of x, so that this exponential function is named as decaying exponential function. That means what? Amplitude of this probability density function has been decreasing with the increment of the value of a random variable, exponential random variable. If the probability density function amplitude is increases with the increment of the x value, that is nothing but it is increasing exponential function. Whatever we took the example, that is nothing but it is decaying exponential function. To get the increasing exponential function, we must select e to the power of irrespective, instead of taking minus value we have to take it is a positive value, so that increasing exponential function will be fx of x, that is a probability density function, is equals to lambda into e to the power of lambda x, and lambda will be chosen as a constant value, that may be integer value 1, 2, 3 like this. We can choose a value such that we can have all the distribution in the for the exponential random variable. This is one of the important thing for from the we can expect one of the problem in the exam. So that here I am going with one particular example. Just now I told that lambda value should not be 0 and x should be greater than or is equals to 0 for the exponential decaying function or the exponential probability density function. X must be greater than or is equals to 0 and lambda must be a constant. By having these two considerations, we can have the standard formula, that is fx of x is equals to lambda into e to the power of minus lambda x. Then I am going with, suppose the waiting time of packets in x in a computer network is an exponential that is random variable. RV stands for random variable, with the formula is given by fx of x. It is standard formula is what? Lambda into e to the power of minus lambda into x. Here lambda is given as 0.5, chosen as 0.5. X value whatever may be, that must be greater than or is equals to 0, so that it is 0.5 into e to the power of minus 0.5. Here lambda chosen, that is 0.5, so that it is e to the power of minus 0.5 into x. Then the probability density function, I am going with the probability density function between the two limits, it is continuous distribution only. As we discussed the binomial distribution and the Poisson distribution, that is for the distinct random variable, whereas the normal distribution and the exponential distribution or the Gaussian distribution is for the continuous random variable. So that in continuous random variable we must choose in the integration, whereas the Gaussian distribution we must choose in that lambda, that is sum. So that I am going with sigma. So that I am going with the probability distribution function between the two limits, that is 0.1 to 0.5. That means what? We can have this integration of 0.1 to 0.5 limit, integral 0.1 to 0.5, that is 0.5 into e to the power of minus 0.5 x dx. So that if you integrate this one, and you can have this one is by substituting the upper limits and lower limits, you can have e to the power of minus 0.5 into upper limit is 0.5 minus e to the power of minus 0.5 into the lower limit is 0.1. In such cases, you can get the probability density functions between the two given limits, that is 0.1 and 0.5, that will be about 0.0241. It is the probability density function PDF of the exponential function or exponential function for the continuous random variable. So that we are going with the another distribution, that is the Rayleigh random variable, that is can be asked for 2 or 3 marks, and it is also very similar to the earlier distributions only. Poisson distribution and the binomial distribution is for the discrete random variables, whereas the normal and the exponential distribution is for the continuous random variable. So that here we are going with the another random variable, that is a distribution that is also named as Rayleigh distribution, and in this Rayleigh distribution we will be considering the variable as the Rayleigh random variable. X is characterized by the PDF, that is probability density function Px of x. That means what? Everybody understand that we have been getting the various probability distribution function for the variable various distributions, Gaussian distributions we have studied, binomial distributions we have studied, Poisson distributions we have studied, and next one exponential distribution, that is decaying exponential distributions we have studied. In all these distributions we have studied only we have studied only probability density function, mean and the variance and the modes of operations. All these we have studied. So that with this all these things again we have to study the Rayleigh distribution variable or Rayleigh random variable, that is given by distribution function is given by fx of x is equals to that is x by sigma square. Sigma we know that it is a mean only, e to the power of x square by 2 sigma square, where x greater than or is equals to 0. When x is less than 0, obviously just now I have explained, if x is equals to 0, that will be anything power 0 by anything will be 0, and 0 by x is less than 0 or x is minus e power of minus something, so that it will be 0 only. So that x is greater than or is equals to 0 only, we can get the PDF, that is probability density function of the Rayleigh distribution. So that here we can where sigma is the parameter of the random variable, but the parameter you can give the name as that is variance of that random variable. So that here we can have the Rayleigh distribution with the Rayleigh variable, that is probability density function for the Rayleigh the variable, that is random variable, is we have explained in the equation. Then I can go with the one particular graph which represents the Rayleigh distribution. That is a distribution is nothing but it is a relation between the probability density function with respect to the random variable. Here the random variable we will be considering it is also the continuous time only, whereas in case of Poisson distribution or the Poisson variable or the binomial variable is for the discrete random variables only. Here this is about continuous, so that we have chosen all the values are continuous from 0 to 20, but we are not mentioning the discrete values from 0 to 2, 2 to 4, 4 to 6. That means what we are treating this is completely continuous variable from 0 to 20, so that we are examining its probability density function from 0 to 20 by selecting the that is a probability density function variable, that parameter lambda is equals to 1, lambda is equals to 2, lambda is equals to 3. Here the analysis is that the probability density function is going to decreases if you choose the mean variance value is more. So that means what? For the more variance values, the probability density functions will be less for the Rayleigh distribution, and the Rayleigh distribution is valid for Rayleigh distribution is also valid for the continuous random variable only. Here the point is very important point is that as the sigma value increases. That means what is the probability density function variable that is parameter. This is a where lambda is the parameter of the random variable. As the lambda value increases, then the probability density function or the distribution is also decreases, so that this is having the inverse relation between the parameter of the random variable and fx of x, where x is a Rayleigh variable and the Rayleigh variable is nothing but it is a continuous random variable. Then I am going with the one particular example in this one, and we can go with the mean and variance. That means what? In all the distributions, that means Poisson's distribution, binomial distribution, then normal distribution. Just now we have discussed the Gaussian distribution, exponential distribution. All these distributions we have to study the mean, variance, and the mode of operations. We have to discuss. In this case, mean is denoted with mu. Generally, mu is denoted for the mean. That is, mean is nothing but average only. It is a continuous distribution, so that the random value has been continuously varying, so that the distribution, that PDF Poisson distribution, probability density function is also keep on varying, so that we can't get any constant value. To avoid this problem, we will be taking the average value, that is mean value. Mean is denoted with mu. Mu is equals to, at final, in the Rayleigh distribution we can get, that is sigma pi by 2 into sigma is nothing but it is a parameter of the variable, that is RV variable, Rayleigh variable. Here from this you can tell directly mu is equals to under root of pi by 2 into sigma. That means what? This mu is directly proportional to sigma, that is there inside of the under root, so that it is directly proportional to the mean is directly proportional to the variable parameter of the Rayleigh variable, so that as this sigma value increases, then the mean value is also increases. Likewise, we can calculate or we can describe the relation between the mean and the variable parameter of the Rayleigh variable. Then we can go with the variance also. Variance is denoted with, in generally, sigma square, but we are also using the sigma as a parameter of the random variable, so that for our convenience we are assuming this variance is about ex square, whereas ex is a mean, whereas ex square is a variance. Then we got that variance is equals to 2 into sigma square. Here also it is directly proportional to the mean is also directly proportional to the value of the sigma. Sigma is nothing but it is a parameter of that Rayleigh random variable. And if you substitute the value of sigma, and you can get that variance is equals to 2 minus pi by 2 into pi square also, so that this is another form of the variance equation. So that from this equation also we will conclude one point is that the parameter of the random variable is directly proportional to the mean and the variance, so that as the parameter of the random variable value increases, then that mean and the variance values also increases. Otherwise, if the parameter of the Rayleigh variable decreases, then the mean and the variance is also decreases. In such a way, we can analyze the relation between the parameter of that particular random variable to the mean and the variance, so that the relation between the Rayleigh distribution and the Gaussian distribution. Just now we have studied the Gaussian distribution. Gaussian distribution, it is nothing new, it is an exponential distribution only, whereas Rayleigh distribution just now we have discussed. So that if you go through this thing, you can get the complete relation between the Gaussian distribution and the Rayleigh distribution, and these two are valid for, we know that these two are valid for the continuous random variable only, whereas Poisson distribution and the binomial distribution is for the discrete random variables, and remaining all the distributions are for the continuous random variables only. So that students, you have to be very careful while you are analyzing any distribution. First you have to first you should know whether it is for continuous random variables or the distribution discrete random variables. After that you should go with the one particular distribution to analyze its mean and the variance and the mode of operation. Then the conditional distribution and the density functions. Conditional distributions, we have studied the conditional probability, that is probability of A is given by B. It is denoted with probability of A by B is equals to probability of A intersection B by probability of B, because probability of A given by B is, that means what, we are considering the effect of probability B, so that probability of A by B is equals to probability of A intersection B by probability of B. This is nothing but it is a conditional probability. By using this conditional probability, we have to go for the conditional distribution and its density function, probability density function, PDF. Conditional distribution function, we know that from the conditional probability, we know that the probability of A by B is equals to, that is nothing but probability of A is given by the B is equals to probability of A intersection B by probability B. And it is clearly conditional probability can be defined on the event involving the random variable X only. We have discussed all these things in the first unit itself only. Now we need to talk about the conditional distribution function, that is conditional distribution function, that is fx of x only. Earlier it is probability distribution function, we have fx of x, but this fx of x is a condition with the b, so that we can go with probability of x less than or is equals to x by b, so that you can go with this can be replaced by this one, and so that you can simply rewrite the equation, that is probability density function, that is a probability distribution function fx of x by b. That means what, the probability density function of x is given by b is given by probability of x less than or is equals to x intersection b by and the probability of b, because we are considering probability of b only, because the conditional probability with respect to the b probability of b only, so that it should not be equals to 0, so that probability of b should not be equals to 0. If the probability of b equals to 0, we can't define this probability function, we can't define distribution function, so that it is distribution function, so that the distribution function is conditional distribution is given by fx of x by b. That means what, we are defining the conditional distribution given by the b, so that it is given from the, it is there from the sets only, that is probability, so that a conditional probability we are defining the conditional distribution, and here probability of b should not be equals to 0, and such that we can have the conditional distribution. Here we can have all the rules, whatever with the rules we have studied in the conditional probability, all can be applicable here. That means what, here we can have the probability of anything must be less than or is equals to 1 only, it must be lies between 0 and 1 only. All these things we have studied with respect to the probability. The same points here we have to note, same point we have to mention here with respect to the distribution, that is conditional distribution, so that this is the conditional distribution. In the tomorrow's class I am going to discuss about the conditional probability density function, that is fx of x by b. With some problems we are going to study the conditional probability density function, so that everything will be clear after solving some problems, and with this second unit will be closed in the tomorrow's class, and from the third unit onwards the PDSP will be very very easy and small only, so that I am not going to take this many hours to complete remaining 3 units, so it will, every unit will take 7 to 8 hours, such that within the 15 to 20 hours we can complete the remaining 3 units, so that students don't waste the time and practice more problems on the PGSP, go through the previous question papers, so that if you find any difficulty in solving the previous question paper, come to me and we will solve all the problems in the class by sitting together. Thank you student, thank you so much, thank you.